Hi friends, welcome to Math A to Z. Today's class from two-dimensional geometry and this topic from rotation of axis or the transformation of coordinate axis. And this is very important word of the transformation of coordinate axis, which is invariant, right? This is very important word of this chapter. Now some quantity or some expression which are unchanged after the transformation of coordinate axis, like rigid motion, like rotation, like translation. This type of quantity or this type of expression are known as invariant after coordinate axis transformation or transformation of coordinate axis. Okay, here we are going to discuss a very important expression which is transformed from ax square plus 2hxy plus by square plus 2gx plus 2fy plus c from this a dash x dash square plus 2h dash x dash y dash plus b dash y dash square plus 2g dash x dash plus 2f dash y dash plus c by using the rotation of axis through an angle theta. Now some quantities which are invariant under the rotation. Here we write the formula of rotation, and we know in the previous class to remember the formula of rotation, we remember the matrix. Okay, and we write here directly the formula of rotation as x, this is equal to x dash cos theta minus y dash sin theta, and y, this is equal to x dash sin theta plus y dash cos theta. Now the quantity which are invariant of this to this are given by number 1 a dash plus b dash, this is equal to a plus b, that is a plus b is invariant, right? A dash b dash minus h dash square, this is equal to ab minus h square, that is ab minus h square is invariant. And similarly 3 and 4 here. To prove the invariance of this quantity, we first apply the formula of rotation, that is we put x equal to this and y equal to this here. Now we arrange this expression like this. Okay, that is we first write a cos square theta here, and we get here b sin square theta, and from this relation we get plus 2h cos theta sin theta into x dash square plus we write this, that is we take common x dash y dash. From here we get minus 2a cos theta sin theta plus 2b sin theta cos theta. From here we get plus 2h cos square theta minus 2h sin square theta, right, plus, and then we take common y dash square, that is from here we get a sin square theta from this, and from this we get b cos square theta, and from this expression we get minus 2h sin theta cos theta, and then we get x dash, that is we take common x dash here and we get x dash from this expression and this expression, that is 2g cos theta plus 2f sin theta plus, and then we take common y dash, that is here minus 2g sin theta plus 2f cos theta, right? And this is C, and we compare this relation becomes this, so we write here a dash x dash square plus 2h dash x dash y dash plus b dash y dash square plus 2g dash x dash plus 2f dash y dash plus c dash. Now comparing the two expressions, this and this, we get a dash, this is equal to this expression, because here a dash x dash square and this is also a dash x dash square, so we get a cos square theta plus b sin square theta plus 2h sin theta cos theta. Okay, and we write this expression as a by 2 here, then we multiply 2, then we get 2 cos square theta. The formula of 2 cos square theta means 1 plus cos 2 theta. Then we get b by 2, that is 2 sin square theta. So this is 1 minus cos 2 theta, and this is h into sin 2 theta. Okay, now we compare 2h dash, this is 2h dash, so we write 2h dash, this is equal to minus a sin 2 theta, this is plus b sin 2 theta, and this is, if we take common 2h from both, then we get 2h into cos 2 theta, because this is cos square theta minus sin square theta. Okay, that is h dash, this is equal to b minus a by 2 into sin 2 theta plus h cos 2 theta. Okay, so we get h dash and a dash. Similarly, if we compare the third term, fourth term and this term, we get a dash, h dash, b dash, g dash, f dash and c dash. Clearly c dash, this is equal to c. Okay, now we write all the term a dash, b dash, g dash, f dash, h dash, c dash. And also a dash can be written as this type. This is a plus b by 2, right? A plus b by 2 plus a minus b by 2 into cos 2 theta plus h sin 2 theta. And b dash can be written also as a plus b by 2 minus a minus b by 2 into cos 2 theta minus h sin 2 theta. Now we prove the result one by one. First result 1. This is a dash plus b dash. Now if we add a dash and b dash, this is a dash and b dash, it is clear that this cancel out, also this also cancel out, and this is a plus b by 2 plus a plus b by 2, that is 2 into a plus b by 2, that is a plus b. Okay, so a dash plus b dash, this is equal to a plus b. So a plus b is invariant. The first result is proved. Okay, now the second result. To prove the second result, ab a dash b dash minus a dash square, this is equal to ab minus a square. We first multiply a dash into b dash. Okay, a dash into b dash, and this is equal to, if we here put a bracket here and this bracket like this, so these two term, this is a dash and this is b dash, so this is a plus b and this is a minus b, right? So if we multiply these two result, then we get the result as a plus b by 2 whole square minus a minus b by 2 into cos 2 theta plus h into sin 2 theta the whole square. Okay, a square minus b square. Now here we put minus a dash square. So a dash is this. Here we put minus b minus a by 2 into sin 2 theta plus h into cos 2 theta whole square. Okay, that is, if we write this result as a minus b, then this is a minus. Okay, so these two factors, if we take common minus from these two factors, then this is a plus. Now if we expand these two square, we get a plus b by 2 whole square minus, from here we get a minus b by 2 whole square into cos square 2 theta, and from here we get a minus b by 2 the whole square into sin square 2 theta. So we get a minus b square into cos square 2 theta plus sin square 2 theta. Okay, this is equal to 1, and from this and this we get h square sin square 2 theta plus h square cos square 2 theta. So we get only h square, and this 2ab term and this 2ab term, this term is plus and this term is minus, so these 2ab term are cancelled out. So we get the total result as like this. Okay, so a plus b by 2 square minus a minus b by 2 square minus a square, and this is also a formula of ab minus a square. So we get a dash b dash minus h dash square, this is equal to ab minus h square. So we prove ab minus h square is also invariant. Okay, now we go for g dash square plus h dash square. This is very simple proof. G dash square plus h dash square means g dash square plus f dash square. This is this square and this square. Okay, so if we expand these two square and summing them, then we get g square into cos square theta plus sin square theta, and from last term we get f square into sin square theta plus cos square theta, and these two ab term and these two ab term cancel out. Okay, so we get g square plus f square. So g dash square plus f dash square becomes g square plus f square. So this is also invariant. Okay, so first three result is already proved. Now we get for the last result. The last result, that is result number 4, is b dash c dash plus c dash a dash plus a dash b dash minus f dash square minus g dash square minus a dash square. Okay, here we take common c dash from first term and we get b dash plus a dash, and we write a dash b dash minus h dash square together, and we write f dash square plus g dash square by taking common minus from these two terms. And we already proved from the first result a dash b dash, this is equal to a plus b, and we get here c dash equal to c. So we put c and this is a plus b, and this becomes ab minus h square, and this is f square plus g square. Okay, so we get ca plus cb plus ab minus f square minus g square minus h square. So we get this result is also invariant. Okay, thank you for